Okay, imagine this. An AI that designs completely new cancer drugs. Not just improving old ones, but creating molecules out of, well, nothing. No prior data, no guides, just pure generative chemistry. How is that even possible? And, what does it mean for where medicine is headed? Welcome to the deep dive. Today we're going to unpack a really compelling collection of insights. It's all from a recent newsletter, really charting the sharp end of AI development. There's a lot to get into.
Oh, absolutely. We're talking about AI skeptics, longtime skeptics, suddenly cutting their AGI timelines in half. We've got these incredible medical breakthroughs that sound like pure sci-fi. And yeah, even some pretty wild AI social media arguments.
Right. So our mission today is to distill all these different threads, give you the key takeaways. Think of it as maybe a shortcut to understanding the big shifts happening in AI right now. We'll try and connect the dots for you.
Yeah, let's unpack it.
So we should probably start with what feels like a really significant shift in thinking. François Chollet, the creator of Keras, that super popular AI library, he's been a pretty vocal AGI skeptic for years.
Very measured.
Exactly. And he just halved his AGI timeline, slashed it from 10 years down to just 5. That's a major change for him.
It's huge. And importantly, he's saying it's not just because models are getting bigger or faster.
Yeah.
It's that AI is starting to get smarter in a way that actually matters.
Yeah.
Moving beyond just being, like he called them, glorified parrots.
He's seeing something else emerge, and this is where it gets really interesting, I think. Chollet is pointing to signs of what he calls fluid intelligence in these systems.
Okay, fluid intelligence.
Yeah, so it's not just pattern matching or remembering stuff. It's the AI's ability to adapt to totally new or unexpected problems on the fly without needing examples or specific training for that situation. It's more like spontaneous problem solving.
Got it. Like, imagine you drop an AI into a simple video game it's never seen. Zero instructions, no labels, nothing, just the game. It has to explore, poke around, figure out the rules just by trying things, and then learn how to win. That's basically what his new benchmark, ARC AGI 3, is testing. It's all about how efficiently it acquires new skills, that raw learning speed.
And humans, well, we can usually figure out those kinds of simple novel games in less than a minute, right? We just kind of get it. Current AI models, still really struggling there.
Yeah, they're not there yet.
Chollet's standard is pretty clear. As long as we can come up with problems humans can solve, but AI can't, we don't have AGI. It's a high bar, sure, but it points to that crucial gap.
But here's an idea that Dorkesh, another AI commentator, really focused on as a potential game changer.
Yeah.
Collective intelligence. He brought up this idea that instead of every AI starting fresh, like a, quote, perpetual intern on day one, any skill learned by one AI could instantly become available to all the other AIs, like instantly shared.
Okay, so connecting that to the bigger picture, that implies AI could compound knowledge almost exponentially, learning not as individuals, but as one giant connected mind, a hive mind.
Pretty much. Dorkesh put it really simply. That would basically be the singularity. It suggests this incredibly fast acceleration where knowledge just builds and builds across the whole network in real time.
So what is it about this collective learning idea that makes it so potentially transformative for AI's progress?
Well, it means AI could share insights instantly, massively accelerating knowledge gains across all systems.
Okay, moving on a bit, we've seen some other interesting updates and notable moments recently that kind of paint a picture of the current scene. There was this clever ChatGPT prompt that apparently went viral.
Yeah, saw that. It's basically a smart way to structure your request to get the AI to think more deeply, giving you better, more relevant answers. It shows users are getting savvier,
Definitely. We're also seeing new GPT-5 model options pop up, names like Auto, Fast, and Thinking. Each seems tuned for different kinds of tasks or speeds.
Right, and GPT 4.0 is back for everyone, but GPT 4.5, that slightly more advanced one, is now only for pro users. The landscape keeps shifting, doesn't it? Companies trying to figure out how to offer different tiers.
And with these new models come rate limits. You get like 3,000 GPT-5 thinking queries a week, which sounds like a lot, but maybe not for heavy users.
But then you look at Claude Sonnet 4, its context window is now massive, 1 million tokens.
And just to clarify for listeners, a token is basically like a word or even just part of a word that the AI processes. So 1 million tokens means Claude can read and understand incredibly long texts, think a whole novel or huge code bases all at once.
Which is amazing. But it comes with higher fees, and right now it's only for their top-tier users, the ones spending over $400. So that power isn't cheap or universally available just yet.
You know, beyond the tech specs, what's also kind of fascinating is the social drama between AIs. We saw the Grok bot on X basically calling Elon Musk a hypocrite.
Oh yeah, didn't see that one.
And then ChatGPT's own social account jumped in and started getting kind of snarky with Grok.
Yep.
It was a public back and forth. It's weirdly human, almost like watching digital rivals emerge.
Huh. Wow.
Yeah.
It's definitely a reminder that these things can be unpredictable, right? And speaking of unpredictable and warnings, there was that really serious incident. A man ended up hospitalized after following diet advice from ChatGPT.
Yeah, that's concerning.
It really hammers home the point. You absolutely must verify AI outputs, especially, when it involves your health or finances or any big decision. It's a powerful tool, but it's not an expert you can blindly trust.
Yeah, I mean, I still find myself having to consciously double-check things sometimes. It's just so easy to trust that confident-sounding answer, especially when you're in a hurry. But yeah, that story is a stark reminder. Vigilance is key.
And on the money side of things, the AI chip startup Revos, already valued over $2 billion, is apparently looking for a big chunk of new funding, like $400 to $500 million.
To compete with NVIDIA, right?
Yeah, exactly. They've already got big names like Intel Capital and MediaTek backing them. It shows the chip race is seriously heating up. Everyone wants a piece of that action because compute power is, it's the foundation for all this AI progress.
So thinking about that diet advice incident, why is that specific case so crucial for us to remember when we interact with AI?
It just really highlights the need for human oversight and checking the facts, especially for anything important.
Okay, let's touch briefly on the sheer amount of money flowing into AI right now. The AI grant report for early August showed some absolutely huge funding rounds. Investment is just pouring in.
Seriously pouring in. OpenAI, for instance, secured a massive $8.3 billion in funding. That's staggering. It's not just investment. It's a huge signal of belief in their long-term AGI goals.
Gives them a lot of runway to pursue those goals without worrying too much about immediate profits.
For sure. And then their open-source rival, Mistral AI, also pulled in $1 billion.
Which is also significant. It shows there's still huge appetite and capital for different approaches, even with a dominant player like OpenAI out there. It suggests a healthy, competitive ecosystem.
Yeah, these are enormous numbers. They really show deep, continuing confidence in the whole AI field. The financial world is betting big that AI is going to reshape basically everything. This kind of cash fuels R&D incredibly fast.
What does this level of investment really signal about where AI is headed?
It signals a very strong belief in AI's continued growth, with the major players pushing hard.
All right, let's do a quick round of other notable AI bits and pieces that popped up. Google's Gemini added some nice features. Temporary chats so they don't save to your history, good for privacy, and more personalization options.
Yeah, letting it adapt more to you over time, user experience stuff, always good.
And there was a change at Elon Musk's XAI. One of the co-founders, Igor Babushkin, left the company.
Oh, interesting. Key people moving around in these AI startups often mean, something's shifting internally.
Yeah.
It's such a competitive space for talent.
OpenAI also put out a clarification. GPT-5 Thinking's context window isn't 32,000 tokens like some thought. It's actually 196,000 tokens.
Oh, that's way bigger. Like more than 5 times bigger.
Yeah, a huge difference. And again, that context window is how much info the AI can hold in mind for one conversation or task. So 196K means it can handle much longer, more complex stuff, documents, deep chats, analyzing code. It's a big step up for professional use.
And Skywork released something called Matrix Game 2.0. They're describing it as being like Genie 3, but for interactive video.
Okay, so that suggests maybe AI generating interactive video content, like experiences that change based on what you do.
Sounds like it. Could be cool for gaming or education, maybe. Creating more dynamic, personalized stuff, definitely one to watch.
And finally, Google is putting a massive $9 billion into expanding its AI infrastructure down in Oklahoma.
$9 billion.
Yeah, that's a huge investment in just the physical hardware needed for AI. Shows their long-term commitment, but also just the immense scale and, frankly, energy required for these advanced models.
So back to that context window point. What's the real implication of having a much larger one for models like GPT-5 Thinking?
It basically means the AI can handle much longer, more complex conversations and process larger documents effectively. Okay, now for something that really stood out, genuinely groundbreaking stuff, Korean scientists have unveiled a new AI model. One that designs cancer drugs entirely from scratch.
Wow, from scratch.
From zero, no starting data needed.
Okay, tell me more. This is bindy, right? It's a diffusion model.
Exactly, bindy. And yeah, it's a diffusion model. Just quickly, a diffusion model is kind of like an AI artist starting with random noise and gradually refining it into a coherent image, except here it's refining noise into potential drug molecules.
Okay.
But the key thing is it's not just making drug discovery faster, it seems to be fundamentally rewriting the whole process.
How so? Because most AI drug discovery now, it starts with known drugs, right?
Yeah.
And tries to improve them.
Precisely. Most current models are like optimizers. They take existing molecules, tweak them a bit, predict if the tweak is good, test it virtually, and repeat. It's iterative, building on what we already know.
But bindy just skips that.
Apparently, yeah. It generates completely new molecules. No templates, no examples needed, just raw generative chemistry. And it designs the molecule and how it binds to its target, all in one step.
Whoa. Okay, so it's like designing the key in the specific lock it fits, perfectly matched at the exact same time, instead of having a key and trying to find a lock.
That's a great analogy, yeah. And it gets better. It optimizes for multiple things at once, like, is it effective? Is it safe? Will it dissolve properly? Stuff that's usually hard to balance.
That's huge.
And here's the really wild part, I think. When Bind finds a design that works, it learns from that success. It recycles the successful strategies it used into future attempts, getting better and better over time. It's got this internal improvement loop.
Whoa. Just imagine scaling that. Running it 1 billion times, generating countless possibilities. And because it doesn't need existing data, that could open doors for treating really rare diseases or mutations we've never even seen before, places where we just don't have the data for traditional methods. That's genuinely revolutionary.
It feels like a completely different way of tackling drug discovery. So how does Bindy's approach fundamentally change the game compared to the older AI methods?
Well, it creates entirely new drugs without needing prior examples, unlike older AIs that mostly just modify existing ones. Sponsor read provided separately.
Okay, let's try and pull this all together. What does this deep dive really tell us? I think it shows AI isn't just getting incrementally better anymore. We're seeing fundamental shifts, real step changes.
Yeah, definitely. We're seeing this move towards actual fluid intelligence, like Joel and I talked about, and this potential for exponential collective learning. That's a huge concept. It points to AI maybe learning and growing at a speed we can barely comprehend.
And at the same time, we're seeing these incredibly transformative applications becoming real, like designing cancer drugs from absolute zero. That could change medicine forever. These aren't just lab experiments anymore. They're starting to happen.
It's such a powerful reminder, isn't it? AI is developing incredibly fast. It brings just immense promise, but also this constant need for us to be vigilant, to understand what we're building and deploying. The excitement is real, but so is the responsibility that comes with it.
So here's something to think about as we wrap up. A question for you to mull over. If AI can now learn collectively as a network and design truly novel solutions without needing any prior data, what kinds of human problems we currently think are just impossible to solve, might suddenly become solvable?
Yeah, that's definitely something to chew on.
We really hope this deep dive helped you connect some of these important dots and feel a bit more informed about this incredibly fast-moving and honestly fascinating world of AI.
Yeah, thanks for diving deep with us today. We'll catch you on the next one. Outro music.